Alright, welcome back. So I'm going to jump right into things for the free response. We're on 2014 part 2, I believe. So we're going to be doing area and volume today. Objectives will be to find the area between two curves and use disk and shell method to create volumes of rotation. So start with this one. So we have can I make this full screen? Yeah. Okay, can you still see? Cool. So our goal here is to first find the area of R. What do I have to do? Okay, so we are part A, we are integrating from 0 to 1, looks good, of, you said x e to the x squared minus negative 2x dx. Okay, this is without a calculator, so we're going to do everything by hand. So what happens here? Then u prime is what? I think I might have lost you for a minute. 2x dx. Okay, so what will happen if I integrate x e to the x squared? Mm-hmm. Perfect. Okay, and this is plus 2x, so what happens when I integrate 2x? X squared, okay, and we're still going from 0 to 1. So if I plug in my upper bound, what's going to happen? Okay, so this will be e over 2 plus 1 for my upper bound minus what? Okay, you're right. So minus 1/2 plus 0 is 1/2. So I've got, if I combine all of this, this is e over 2 plus 2 over 2 minus 1 over 2 is e over 2 plus 1 over 2 is e plus 1 over 2. Okay, and that's part A. I think I'm going to try to do part B over here on the same side since we can see the problems here. So for part B, we want to write but not evaluate an integral expression that gives the volume of the solid when r is rotated about y equals negative 2. Right. Let me first make sure we don't cross that. So when x is 1, what's my lowest point for this bottom function? Yep. What's the lowest y value that we get when we're at this bottom function? Minus 2. Okay, so we don't have to worry about crossing our axis at all, which would have been a headache. So here's our axis of rotation that we are going to spin this about at y equals negative 2. Okay, so if I'm spinning about y equals -2, is this... Do you think we should use this method or shell method for this? Okay, this method, you're right. Why? Right, so as long as we have functions y in terms of x, then you'll want to use this method when we're rotating about when we're rotating about a horizontal line, and shell method when we're rotating about a vertical line. Okay, so what's our formula? Okay. Perfect. So what we just did was we got the difference between your upper y and our axis of rotation. So that's this minus -2 or this +2. And our difference from your lower one in the axis of rotation. So that's -2x minus -2 or -2x plus 2. Both of those would have created circular disks with those radii. If I cut the smaller disk out of the bigger disk, we'll end up with a hole. If I keep stacking those on top of each other, we'll end up with a 3D shape. So that's pi r1 squared minus pi r2 squared is cutting the middle disk out of the larger disk. Okay, then the last one. Write but do not evaluate an expression involving one or more integrals that gives the perimeter of R. Yep. So I'm going to erase all of this stuff. Okay. So we'll need... You've got it, keep going. So arc length, I assume for the top function, right? Okay. Arc length is equal to what? Okay. Okay, I think you said it earlier, but we kind of backtracked for the integral. So integral from 0 to 1 of what? Right, square root of... Okay. Um, so when I go to derive this, product rule. Okay, so I'm going to do that up here, I think. Y prime is equal to what? times e to the x squared. Okay, this needs to be squared. F prime x squared. Dx over dx squared plus dy over dx squared. Okay, so, okay. I think I'm gonna leave it like that actually. We'll just plug this in. So that'll be my arc length of, I'm gonna call this y1 and y2. So arc length of y1. I still need, in order to get the perimeter, 2 more distances. So what else do we need? Okay, the vertical line, that should be the easy one. You told me earlier this was y equals -2. What is this top line then? If you plug in 1. Okay, e to the... well, it's e to the 1 squared is just e to the 1, right? So that's just e. Okay, so what's the total distance from here to here? E plus 2. Okay, so I've got vertical equals e plus 2. Okay, then I've got the length of y2 for the last part. How can we get the length of y2? Okay, so if we do Pythagorean Theorem, we said this length is how much for the vertical? 1 for the horizontal. How much for the vertical? 2. Okay, and then we can solve for c. Yeah, that's okay though, so they don't have to draw these to scale. Okay, so if we solve for c, what's going to happen? Okay, c squared equals 1 plus 4, or c equals root 5. Okay, so that's the length of y2 is root 5. If I was doing this in the AP exam, I would want to move this down to the part C. That way they can grade me for my work. I'm just doing this up here so that I can keep the figure in the same screen. So now we just need to add all 3 of these together and we should be good to go. So the perimeter is equal to root 5 plus e plus 2 plus the integral from 0 to 1 of the square root of 1 plus f prime, which we said was this, and e to the x squared plus 2x squared e to the x squared. All squared in terms of x. And we should be good. Any questions on anything we did here? Okay, I'm going to check the scoring guides really quick. Dun, 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 dun. This was question 4. Nope, 5. Okay, so we've got our area, 1 point for integrand, the antiderivative, and the answer. Okay, I know I've got the answer right. Oop, not writing. There we go. Answer right, our antiderivative. Okay, we've got that, and our integrand. Okay, we're good. 2 points for the integrand, 1 point for the limits and the constant. Okay, that's pi 0 to 1 we had. 2 points for the integrand. I'm going to assume they're both R2 and the R1. That looks good. Okay. Then 1.4 deriving. Okay, they just factored that out, but we've got the same thing. So that's fine. Our integral from 0 to 1, and we did this squared. Okay, that's good. And our answer, root 5 plus 2 plus e plus the integral. Okay, good to go. So we should get 9 points out of 9 for that, I think. Awesome. All right, so I'm going to leave this up to you. In previous years, because we're so close to the AP exam, I've offered tutoring sessions through spring break. I'll take a final answer on this tomorrow when I see you for physics. But do you want to have tutoring over spring break? So extra problems?
I think I can just take rest and have to study enough.
Okay. So I'll go to the AP classroom and I'll pick out a couple problems for the physics class. So if you want to work on it, you'll have it available. But again, so the last 4 problems we've worked on for physics, you've averaged 14 out of 15 points. And I think you've aced everything for Calc BC for the past 3 homework assignments. So you're doing awesome on the free response questions for both classes right now, and I'm not really worried about you at all. So if you want to take a break, I'm okay with you taking a break.
But for the AP test,
Yes.
do you think they will make a new type of question or just use the same FI2?
I imagine the questions are going to be similar. However, they might cut parts of the free response to be shorter. So they've got a lot that they need to cram in 45 minutes, and they're only doing free response questions to do it. We should know for sure on April 3rd U.S. time, which is actually Saturday this week. If you want, I can meet you once during the spring break for a Skype session. We can arrange through WeChat, and we'll just talk about the changes maybe at the start of next week. So we'll get them on Saturday. So that should be like 10 minutes or so. I'll read through it over the weekend and come back to you maybe on Monday. Okay, what time on Monday works for you? Morning time. Okay, so let's stick to this time slot then. So we'll do 10 a.m. if that's okay. Briefing on AP changes after College Board's release. Okay, if for whatever reason College Board delays it, I'll let you know on WeChat. Okay, thank you very much, and I'll see you tomorrow for physics.